Hi everyone, myself Chandrapatap Reddy M from the Department of Electronics and Communication Engineering. Today we are discussing about baseband signal receiver from the subject analog and digital communications. Baseband signal receiver and its how signals are received and processed in baseband systems. Introduction to baseband systems. Baseband systems are used to transmit signals at low frequencies without modulation. They are essential in applications such as wide communication and local area networks. Understanding their operation is crucial for designing efficient communication systems. Here shows a diagram about digital communications. It is a one type of baseband pulse transmission. Starting is workstation and then digital signal. It is also called as baseband signal and then modem. After that modulated analog signal. It is also called as broadband signal. What is baseband signal? A baseband signal contains the original information signal without any modulation. It typically covers a frequency range from 0 Hz up to a certain bandwidth limit. Baseband signals are directly used for transmission in wide media like coaxial cables. In telecommunications and signal processing, baseband is an objective that describes signals and systems whose range of frequencies is measured from close to 0 Hz to a cutoff frequency, a maximum bandwidth or highest signal frequency. It is sometimes used as a known for a bandwidth of frequency starting from close to 0. Baseband can often be considered as a synonym to low pass or non-modulated and antonym to passband and band pass carrier modulated radio frequency. Components of a baseband receiver. A baseband receiver consists of several key components including filters, amplifiers and analog to digital converters. Each component plays a role in ensuring the received signal is accurately processed. The efficiency of these components directly affects the quality of the received signal. Here the components of a baseband receiver. First one is matched filter, timing corrector and then detector, after that transmitter. It can be feedback to input as timing estimator. Signal reception process. The first step in signal reception is the capture of incoming signals through an antenna or cable. The captured signal is usually weak and requires amplification for further processing. Initial filtering is essential to remove unwanted noise and interference from the signal. Here figure shows about how antenna works. Transmitter receives signal. Electromagnetic wave transmits through space. Antenna that generates electromagnetic wave. Antenna that receives electromagnetic wave. Transmitting antenna. When the alternating electricity pushes the electrons of the metal conductor of the antenna to vibrate up and down, it generates electromagnetic wave. Receiving antenna source. When electromagnetic beam falls on the receiving antenna, it intercepts some of the power of the radio wave in order to produce an electric current and its terminals. Amplification of the signals. Amplification increases the strength of the received signal to improve its processing capability. Operational amplifiers are commonly used for this purpose in baseband receivers. The goal is to reach a level where the signal can be effectively digitalized and analyzed. Here the sum of the signal strengths can be shown in this figure. The amplitude between -130 to -110, it is none, and the amplitude between -20 dBm to 100 dBm, it is poor, and then amplitude between -10 dBm to -90 bdm, it is fair, and then amplitude between -100 dBm to -80 dBm, it is good, and the amplitude between -90 dBm to -70 dBm, it is very good, and then amplitude between -80 dBm to -60 dBm, it is excellent. The amplitude between 4G and 3G, it is a signal strength. Filtering techniques. Filters are employed to eliminate the noise and unwanted frequencies from the signal. Common filtering methods include low pass, high pass, and band pass filtering. Proper filtering ensures that only the relevant portions of the signal are retained for processing. Analog to digital conversion. It is also called as ADC. ADC is a critical step in baseband signal processing, converting analog signal into digital format. This conversion allows for easier manipulation and storage of the signals in digital systems. The quality of the ADC affects the accuracy of signal representation and subsequent processing. Signal processing techniques. Baseband signal processing involves various techniques such as sampling, quantization, and modulation. These techniques help in extracting meaningful information from the received signal, and advanced processing algorithms can enhance signal quality and reduce errors. Here is the signal processing techniques. First one, pre-processing, DC offset calibration, demodulation and phase unwrapping, residual phase removement, synchronous squeezing transform. It is classified into two types, respiration and heartbeat. In respiration, ridge extraction and heartbeat ridge extraction. Ridge extraction can be represented as FR of T. Heartbeat can be represented as FH of T. It is converted into reconstruction of heartbeat and respiration signals. Demodulation process. While baseband systems generally deal with unmodulated signals, demodulation can be necessary in some contexts. This process involves extracting the original information from modulated signals if present. Demodulation techniques can vary based on the modulation scheme used. Implement delta modulation and demodulation blocks for the digital input. Error detection and correction. Error detection and correction techniques are vital role for ensuring data integrity in baseband systems. Methods like checksums, parity bits, and cyclic redundancy checks are commonly applied. These techniques help to identify and correct errors that may occur during transmission. Signal reconstruction. Signal reconstruction involves converting the processed digital signal back into an analog form if needed. This step is critical for applications where the output must be in a human readable format. High quality reconstruction ensures that the original signal characteristics are preserved. Applications of baseband receivers. Baseband receivers are widely used in networking, telecommunication, and audio systems. They play a crucial role in ensuring reliable data transmission in various applications. Understanding their function helps in improving performance across different technologies. Challenges in baseband signals. Baseband processing faces challenges such as noise interference and signal degradation. The limited bandwidth of baseband signals can also restrict data throughout. Addressing these challenges requires ongoing advancements in technology and techniques. Narrowband and broadband signal classification. Idealized example of narrowband signal which fits within a receiver band in figure, and broadband whose energy does not fit within a receiver broadband. Future trends in baseband technology. Emerging technologies are driving the evolution of baseband systems, including software-defined radio. Increased integration of artificial intelligence is enhancing signal processing capabilities. Future trends focus on greater efficiency, higher data rates, and improved reliability. In comparison with modulated systems. Unlike modulated systems, baseband systems maintain the original signal characteristics without distortion. They generally require simpler receiver designs compared to their modulated counterparts. However, baseband systems may struggle with long distance transmission due to signal loss. Here is the difference between baseband versus passband transmission. Baseband signals, if voice signals is transmitted from 0 to 4 kHz, TV signals is transmitted from 0 to 6 MHz. A signal may be sent in its baseband format when a dedicated wire channel is available. Otherwise, it must be converted into a passband. Importance of bandwidth in baseband signals and systems also. Bandwidth is a critical factor in determining the capacity of a baseband system. Limited bandwidth can lead to reduced data rates and increased signal distortion. Optimizing bandwidth usage is essential for maintaining signal integrity and performance. Different definition of bandwidth: half powered bandwidth, noise equivalent bandwidth, null to null bandwidth, fractional power containment bandwidth, bounded power spectral density, absolute bandwidth. Role of signal to noise ratio is simply called as SNR. SNR is a key measure of signal quality in baseband systems, indicating the level of noise relative to the signal. A higher SNR generally leads to better performance and accuracy in signal processing. Techniques to ensure SNR can significantly improve the overall efficiency of the communication systems. SNR is a measure of signal quality is related to signal power, and noise power is represented in decibel and is given by the following formula. SNR equals to 10 log of P signal by P noise. Write a function that takes signal and noise powers as arguments and returns SNR. Write a program that calls the above function iteratively for signal power values from 1 watt to 10 watts in steps of 1 watt, with noise power being constant at 1 milliwatt. Display the SNR values from the main program. Case studies in baseband signal processing. Case studies demonstrate real-world applications of baseband receivers in various industries. These examples highlight the effectiveness of bandwidth systems and in different scenarios. Analyzing case studies helps in understanding best practices and potential improvements. Summary and its key points. Baseband signals receivers are essential for efficient communication in various domains. The process involves multiple steps including reception, amplification, filtering and processing. Ongoing advancements continue due to enhancements the capabilities and applications of baseband systems. Efficient VLSI architecture for baseband signal processing in wireless baseband station receivers. Conclusion. Baseband signal receivers plays a vital role in modern communication systems by accurately processing incoming signals. The combined process of amplification, filtering, and analog to digital conversion create a foundation for effective signal analysis. As technology advances, baseband processing continues to evolve, improving performance and enabling new applications. Thank you.